This diagram shows the principle of total rebreathing. The patient is given a continuous flow of anesthetic gas, represented by white spots, and oxygen, represented by white circles. The gases are inhaled by the patient and exhaled unchanged through the open tap on the bag. The black spots represent the carbon dioxide, which is also exhaled by the patient. We will now show the cycle. Gas and oxygen are breathed in from the bag and the machine. Gas and oxygen and carbon dioxide are breathed out into the bag. Some escapes through the open tap. When the required level of anesthesia has been reached, the flow of anesthetic gas is cut off, the valve is closed, and the patient breathes the same gases to and from the bag. A small flow of oxygen must be given to replace what the patient is using up. But as you see, when the flow of fresh gases is reduced, the carbon dioxide exhaled by the patient begins to accumulate in the apparatus. This would act as a poison if inhaled for long. To overcome this, a canister of specially prepared soda lime is put between the mask and the rebreathing bag. This will absorb the excess carbon dioxide. The canister must be large enough to contain all the expired air. Here is one type of canister used. The screw top is fitted with a wire gauze mesh to keep the soda lime in place. Fill the canister with soda lime from a container. It must be packed tight, or there will be a space when it's turned on its side, through which some of the gases can pass, leading to incomplete absorption. Make sure the canister is airtight by closing one end with the palm of your hand and blowing through the other. Blow through again 2 or 3 times to clear out soda lime dust, which is irritating if inhaled. If you pour in a little water, the soda lime will reach maximum efficiency at once. The canister is now ready for use. Put on a strip of adhesive plaster and mark it off in sections. A cross in each section represents 1 hour's use. You'll get about 8 hours absorption from one filling, but it becomes less efficient after 2 or 3 hours continuous use, so have a spare canister ready. The canister is placed between the rebreathing bag and the angle piece, to which the face mask is attached. The oxygen lead is attached to the angle piece. The rebreathing bag has a tap at the far end through which the expired gases can pass. When the tap is closed, total rebreathing takes place through the canister. Here you see the apparatus fitted on the patient. This single-phase apparatus works in exactly the same way as the diagram you've seen. The gas is passing over the soda lime during both expiration and inspiration. Anesthesia is induced with nitrous oxide and ether in the usual way, without the canister. When the required level is reached, plug in the canister. When the bag is filled again, close the tap. Turn off the nitrous oxide and lower the oxygen flow to 300 cubic centimeters a minute. You can leave the ether tap on for 10 minutes to compensate for the loss of anesthetic into the tissues. The oxygen consumption of a patient varies from 200 to 400 cubic centimeters a minute. This is called the basal oxygen flow. The exact figure is reached by watching the rebreathing bag over a period of time. Here the bag is of normal size. If you find that it gradually fills, the oxygen flow is too high and must be cut down. If the bag gets smaller and there's no leak, the oxygen flow is too low and it should be raised. This is the simplest method of carbon dioxide absorption. It's efficient, but there's a possibility of the patient inhaling dust from the canister if he's breathing very deeply at first, and the canister gets very hot from the chemical action. The alternative method is called closed-circuit or two-phase absorption. A narrow-bore tube for the fresh gases runs from the flow meters to the Y-piece. The rebreathing bag and the canister are attached by two tubes, corrugated rubber hose, to the Y-piece and face mask. At one end of each tube is a directional valve, so that the patient expires through one tube and inspires through the other. Various circuits are possible, but this one is common. The fresh gases from the gas-oxygen machine flow to the Y-piece, as in single-phase absorption. The exhaled gases pass along the expiratory hose, over the valve, through the soda lime canister, where the carbon dioxide is absorbed, and into the rebreathing bag. On their return path from the bag, the inhaled gases do not go through the canister, but pass over the valve and along the inspiratory hose to the patient. We will now repeat the cycle. As you see, the two phases of respiration are kept separate by means of the directional valves. The gases pass through the absorber only once in each cycle of respiration. The advantages of this method are that the bulky canister is kept well away from the face, and the gases have time to cool on their way from the canister to the patient. Here is the model you saw in the diagram, attached to the gas-oxygen machine. The fresh gases pass from the flow meters through this narrow-bore tube to the Y-piece and face mask. On On the top of the canister are the directional valves. Here you see them working. An ether bottle is incorporated into the apparatus and placed between the rebreathing bag and the circuit. The flow of gases through the bottle is regulated by this tap. It works like this. When the tap is turned off, the gases pass along the top and don't go through the bottle. When the tap is turned on, the gases pass down one side of this partition, through the wick, the lower end of which dips into the ether, and up the other side to the rebreathing bag. On their return path, the gases again pass through the bottle and into the circuit. As none escapes from the circuit, a high concentration of ether is built up quite rapidly. The expiratory valve can be anywhere in the circuit. This machine has a valve on the side of the canister mount. This dial indicates how many hours the absorber has been in use. Adjust it at the beginning and end of each case. The base of the dial is the absorber tap. This controls the circuit of gases. It moves from off through various intermediate positions to full on. Two circuits are possible on this type of machine. When the absorber tap is turned off, the canister is cut right out. As the absorber tap is turned from off by degrees to full on, increasing proportions of gases are sent through the canister until complete absorption is reached when they are all passing through the canister. When you've filled the canister as before, screw it into place. This canister is fresh, so turn the dial to naught. Turn the absorber tap to off. Now induce anesthesia with nitrous oxide and oxygen in the usual way. The expiratory valve is left open for the first 5 minutes to wash out the nitrogen contained in the apparatus and the patient's lungs. Introduce the ether gradually. Now close the expiratory valve. Turn off the nitrous oxide and lower the oxygen to your basal level. Bring the canister into the circuit by turning the absorber tap full on. The patient is now fully anesthetized. Readjust the mask. Add more nitrous oxide and oxygen to fill the bag again. And turn off the ether vaporizer. Turn off the nitrous oxide and lower the oxygen again to your basal level. Once anesthesia has reached the required depth, it should, theoretically, remain at about the same level without addition of any more ether.